between the control and the concrete blasts, they'll measure two parameters. First, the shrapnel.
We want to know how dangerous the shrapnel might be, so we are implementing shrapnel catchers. We have cut out a ton of plywood dudes that we are going to place on a 30-foot radius between us and the blast so that we can see if chunks of metal fly off, will it kill someone standing that far away? Let's mullet it up! You know, while it's universally agreed that MacGyver brought ingenuity and cool problem-solving to network television, it's not often discussed what he's done for the mullet. Business in the front, party in the rear.
The second parameter is the pressure wave.
We'll be gathering precise data on the strength of our blast using one of these. This is a pressure transducer. Our blast obviously will put out a tremendous amount of energy, most of it in the form of a blast pressure wave. That wave will meet our pressure transducer. It'll exert a little mechanical energy on a tiny crystal inside the transducer called a piezo. When we hook it up to a computer, it gives us exactly how strong the blast pressure wave was, where that pressure transducer was placed. Having all three of these data points for both blasts ought to give us a really good picture to see if MacGyver's cement made a difference between the control and the cement blast. Mr. Heineman, you ready?
Okay, arming and ready.
This is MacGyver Control Empty Postal Van, 84 pounds of TNT in 3, 2, 1. Ooh! That, I think there's still some stuff flying through the air.
Yeah, nobody go outside yet.
No.
What goes up comes down.
Yep, you've got hail. A hail of metal shrapnel.
Oh, look, the eagle has landed.
And plywood shrapnel catchers.
That's gotta hurt.
It's pure carnage for our shrapnel catchers. Legs and hands and mullets everywhere.
The blast was significantly more powerful than expected. At 30 feet, the shrapnel damage was clearly catastrophic. But what about the pressure sensors?
Oh.
Whoops.
It looks like all three of the sensors we had out here are totally busted.
With the cables for the pressure transducers shredded, even at 250 feet, they have no control data. And the next step will take some figuring out. So it's on to story 2, where the guys are breaking new ground by going underground.
So, landmines.
Yep. The myth is if you want to cross a minefield and you want to do it safely, which I assume you do, the vehicle of choice is a hovercraft.
And that would be because the hovercraft doesn't set them off.
That's the myth. That's what I think we should test.
You know, I don't think I've ever driven a hovercraft.
Especially over a minefield. One stick of dynamite.
This is a story of firsts. Over the years, the team has tackled every conceivable explosive tech. Except one, landmines. But first, this story's other first, the state-of-the-art craft in question. Supposedly, a hovercraft is perfect for safely traversing a minefield because it evenly distributes its weight on a cushion of air. To find out the truth, our novice riders require lessons.
We got the left and the right steering, and we have the throttle. That provides both the lift and the thrust.
Once in the driver's seat, Adam discovers it's surprisingly easy to handle.